Assalamualaikum and hi guys. So today we are going to continue for chapter 8b, that is the two-way analysis of variance. Okay, if in our previous lesson we are going to discuss about one-way ANOVA by using a completely randomized design or CRD design. So in this chapter, we are going to discuss about two-way analysis of variance, that is two-way ANOVA, by using the completely randomized block design or CRBD. So first of all, if you remember in our previous lesson, I also provide to you the notes about one-way and two-way ANOVA. So what is the difference between one-way and two-way ANOVA? So one-way ANOVA basically a situation when we want to test the measurement that allows one to make comparison between the means of 3 or more groups. Okay, and the number of independent variables usually is 1. That is one-way ANOVA. But in contrast, two-way ANOVA is a test that allow us to make a comparison between the means of 3 or more groups of data, and the situation is where the two independent variables are considered. So one-way ANOVA, usually we have one independent variables, but in two-way ANOVA, we have two independent variables. Okay, and in one-way ANOVA also, the number of group sample usually refer to 3 or more, but in two-way ANOVA, the number of group samples usually refer to the multiple samples. Okay, so that is the difference between one-way and two-way ANOVA. So in this chapter, we are going to continue to discuss about what is two-way ANOVA and how we are going to analyze using the CRBD design for two-way ANOVA. Okay, so the CRBD is actually the direct extension of the pair difference or match pair design from the Z or the T test. Okay, and it is a two-way classification in which K treatment means are compared. And the design uses also blocks, okay, of K experimental unit that are relatively similar or homogeneous, with one unit within each block randomly assigned to each treatment. So that means in two-way ANOVA, we are not only refer to the treatments, but we are also refer to the other types of experiment that is blocks. Okay, that is referred to blocks. Okay, so when we talk about CRBD, okay, so in CRBD, it is also like CRD, okay, where Xij be the response for the I treatment applied to the J block. Okay, but so the difference is only in two-way ANOVA, we not only refer only to treatment, but we must also refer to the block. Okay, and the total variation in the experiment is also measured by the total sum of square. Okay. So if in one-way ANOVA that use the completely randomized design or CRD, we must also usually we have it is a strong recommendation for us to make the table. So same for the two-way ANOVA that using the CRBD designs. So it is very recommended to draw the table so we can see what are the analyses that we need to measure and we need to count so that we can get the test statistic of F value. Okay, so if in one-way ANOVA that use the CRD design, they are only referred to the treatment and error. But now in two-way ANOVA that uses the CRBD design, we are also referred to the blocks. So in a two-way ANOVA, that is another row that must be added into the table, that is the block row. Okay, so how to get the degree of freedoms? Okay, the degree of freedoms for treatment is the treatment minus 1, and the degree of freedom for block is the value of block minus 1. Okay, and the total error is like shown in this table. Okay, and how to get the sum of square for treatments? It is referred to as ST, and sum of square for block is referred to as SB, and sum of square for error is referred to as SE. So how to get the mean square? The mean square for treatment. Okay, so SST divided by treatment minus 1, and how to get the mean square of block is SSB divided by block minus 1. So how to get the MSE is when we need to divide the value of SSE with block minus 1 times treatment minus 1. So in F statistic or test statistic of F for two-way ANOVA that use the CRBD design, we have two value of F statistic. The first one is the value when we compare the value with the treatment. So that is MST divided by MSE. And the other one is when we compare the MSB divided by MSE. So we can refer to this either one of value of test statistic, either the F value of test statistic for treatments or block. But usually the main comparison that we usually refer to is the treatment. Okay, usually we are going to compare the value of F statistic for treatment. Okay. So this is the formula, okay, that we are going to use in a two-way ANOVA by using CRBD design. Okay, this is for mean of square, how to get MSC, MSP, and MSE. Okay, so in two-way ANOVA table of CRBD, okay, the total of sum of square is divided into three parts. That is the SST. It is referred to the sum of square for treatments. Okay, so the measures the variation among the treatment means, and it's also referred to the sum of square of blocks, and the third is the sum of square of error. So the total value, that is the total sum of square, is equal to SST plus SSB plus SSE, and the degree of freedom, the total degree of freedom is referred to degree of freedom treatment plus degree of freedom block plus degree of freedom error. So this is the formula. Okay, it is also same like one-way ANOVA that use the completely randomized design or CRD design, where the value of CM must refer to the grand total value square divided by n. Okay, so the first situation is we must get the value of CM, that is the grand total, the value of grand total square divided by value of n. And the second step is we need to find the value of sum of square. Okay, so the total value of grand total square, and then minus the value of cm. Okay, and the third step is refer to the value of SST. So to get the SST, the total value for the treatment divided by the value of block, okay, and minus cm. And the fourth step is we must calculate the value of SSB. So how to get the value or the sum of square for block is the where the total value for block divided by the value of treatment, and then minus the value of cm. Okay, and the fifth step is we need to get the value of SSE. So how to get SSE? So the total sum of square must minus with sum of square treatment and minus with sum of square block. Okay, so this is all the formula that we are going to use in two-way ANOVA of CRBD. Okay, now let's see the example. So this is the basic examples. Okay, I will provide to all of you another example in a short video later. Okay, so now let's see the example first. Okay, this basic example first. Okay, the problem is about the seedling problem. Okay, now determine whether there is any difference of soil preparations for the various locations. So usually in two-way ANOVA, because it not only refer to treatment but also refer to block, so they not only give you the treatment. That means not only give you, for example, in this question, it not only give you the problem about the soil preparations, but it also refer to the location, various location. Okay, so in these conditions, so the situation is they want you to determine whether there is any difference of soil preparations, okay, for the various location. So soil preparation is referred to treatment. Okay, so maybe in one-way ANOVA, okay, in one-way ANOVA, the question is only stop here. That means determine whether there is any difference of soil preparations. So it refers to treatments only. But now, the question is also want us to determine the difference between soil preparation and for the various location. Okay, so it refer also to the other variable that is various locations. So it refer to the blocks. Okay, so that is two-way ANOVA. Okay, so this table has been given. Okay, they give you the locations. Okay, they give you the 4 locations, 1, 2, 3, 4, and they give you the 3 treatments. That is A treatment, B treatment, and C treatment. Okay, the soil preparation is the treatment. So this one is treatment. Okay, this one is treatment. And the location is referred to the block. So now, location or block, we have 4. And soil preparation, that is the treatment, we have 3. That is A, B, C. So in this question also actually, A is referred to no preparation. Okay, this is referred to no preparation. And B is refer to fertilization, okay, and C is refer to burning. Okay. Okay, so in our first step, same like one-way ANOVA, okay, we must count all the value for the locations and soil preparation. So the total value for treatment for 4 locations for soil A, okay, so that is 50. And for B, the treatment for 4 location is 64, and the total treatment for 4 location for C is 48. Okay, so you must also get the value of block. Okay, so now for 3 block, for first location we have 36, and then 45, 49, and 32. So the total value is the total value for treatment and block is 162. Okay, now let's proceed to the first step. The first step is we need to find the value of cm. So when we refer to the formula, okay, so the total value square divided by the value of n. So n here is referred to 12 because we have 4 locations and 3 blocks. So 4 times 3 we get 12. Okay, so 162 square divided by 12, you will get 2187. Okay, now second step, you must get the total value of sum of square. So the total value of sum of square is you must add all the value and square, then minus the value of cm. So it starts with 11 square, this one, 11 square, okay, and then plus 15 square, okay, and then you plus 10 square, and then plus 13 square, and then you plus 70 square, and you plus all this value until 10 square, okay, and then you minus with the value of cm, that is 2187, then you will get 111. Okay, and in the third steps, you must get the value of SST. So how to get SST? The total value of the treatment, and then you square, okay, this one, the total value of treatment, 50, 64, and 48, and square each of them and divide by 4. 4 is referred to the value of block. Okay, so we have 4 location, that is 4 block. So divide by 4 block and minus with the value of cm, then you will get the answer is 38. And then in fourth step, you must get the value of SSB. Okay, the sum of square of block. So how to get sum of square of block? That is the total value of the block, that is 36 square, 45 square, plus 49 square, plus 32 square, and divide by the value of treatment. So the treatment here is referred to ABC, that is 3. So divide by 3. Okay. This is the value of treatment. Don't confuse, okay. To get the value of SST, okay, it must divide with the value of block. Okay, but to get the value of SSB or block, it must divide the value, it must be divided with the value of treatment. Okay, so be careful with the formula. All right, and then after you get the value for all the mean average for all the blocks, okay, and then minus with the value of cm, then you will get 61.6667. Okay, now in the fifth steps, you must also get the value of SSE, that is sum of square of error. So how to get SSE? The value of total SS minus the value of total SST and minus the value of SSB. So you will get the answer for SSE is 11.3333. Okay, so this is the formula how to get the degree of freedom. Okay, degree of freedom for total degree of freedom for treatment, degree of freedom block, and degree of freedom error. Okay, and this is also the formula how to get the mean square for MSC, MSB, and MSE. Okay, so in this table, they show you all the formula for degree of freedom, total sum of square, the mean square, and the value of test statistic. Okay, now we back to the examples. Okay, we already get the value of cm, the value of total sum of square, the sum of square for treatment, the sum of square for block, and the sum of square for error. So after we get all the values, we must convert into the table. Okay, so how to get the degree of freedom for treatment? Okay, it refer to the formula here. That means treatment minus 1, and the degree of freedom for block is block minus 1. And same also for how to get MST, MSB, and MSE, is going to refer to all these formula. So after you calculate all the value based on the formula that have been given, you must enter all the value in the table. Okay, please try to calculate and try to convert all the value in two-way ANOVA table. Okay, so after you have calculate all the value, so you will get the value for F, or test statistic of F for treatment is 10.06, and for blocks 10.88. Okay, now how we are going to interpret our analysis or our results. So first of all, we must state our hypothesis. Okay, same like the one-way ANOVA, we must state first our hypothesis. So the first one, we must state the null hypothesis. So the null hypothesis must be the mean or the mu1 equal to mu2 equal to mu3 until the end of the mu. If there are so many mu, you can only state the first 3 mu, okay, and then you just put dot dot dot, and then equal to the last value of the mu. If you have 14, so just state 14. If you just have 4, if you just have 7, so just state mu 7, for example. Okay, so this is just the example, okay, on how you are going to state your null hypothesis. And after you stated your null hypothesis, you must also state your alternative hypothesis. So in these conditions, your alternative hypothesis is referred to at least one mean is different. Okay, at least one mean is different. So to test our null hypothesis, Okay, so that treatment or the block means must equal. So how to test our statistic of F? That is referred to the MST divided by MSE, or we can also refer to the value of MSB divided by MSE. Okay, so we are going to reject our null hypothesis if our F test statistic is greater than the value of F alpha that we have referred in the table. Okay. Okay. So testing, when we testing the treatment and block, okay, remember also that the standard deviation is the common variance for all block and treatment combination. So MSE is the best estimate of standard deviation, whether or not the null hypothesis is true. So if the null hypothesis is false and the population means are different, okay, then the MST or MSB, all right, whichever you are testing, that means either MST or MSB, okay, will unusually large. Okay, will unusually large. Okay, so the test statistic that is F equal to MST or MSE, or F equal to MSD divided by MSE, tends to be larger than usual. Okay, so we use a right tail F test with the appropriate degree of freedom. So that means we are going to refer to the F test table, all right, and refer to the degree of freedom as we use and we apply in one-way ANOVA. So based on this example, okay, so now based on this example, we get the value of F test statistic for treatment is 10.06 and the F test statistic for blocks is 10.88. Okay. Now, okay, to test for a difference due to soil preparation, okay, now the null hypothesis that we state is mu1 equal to mu2 equal mu3, okay, and then for our alternative hypothesis, we stated that at least one mean is different. So now the F value is MST divided by MSE, okay, we get 10.06. Okay, that is the value of treatment, this one. Okay, 10.06. So we are going to reject the null hypothesis if the F value is greater than the F value of alpha 0.05 in our F table. So now, first of all, let's say they give you the alpha value that is 0.05. Okay, in this question, they give you the alpha value is 0.05. So first of all, you need to find the value of F in F table that have the alpha value 0.05. Okay, now in F table, as I mentioned you earlier, the above value is referred to the value of the E numerator. That means the value of the degree of freedom for treatments. That is 2. Okay, and this column, all right, is referred to the value of this column is referred to the value of the degree of freedom for denominator. So that means it refers to degree of freedom of error. So in this question, degree of freedom of error is referred to 6. So this one. Okay. So 2 and 6, that must be around here. Okay, now they give you the alpha value is 0.05. So you must refer to the alpha that is 0.05. So the F value is 5.14. Okay, so now the value of F statistic of your treatment is 10.06, and the value that have been measured in our F table is 5.14. Okay, and if you try to draw the graph, but although is in graph, actually we not refer to F. Usually we are going to refer to the Z value. Okay, but let's say if you draw the graph, okay, so the value of F, okay, the value of F F that have alpha 0.05, okay, alpha is 0.05 is referred to 5.14. Okay, so now your test statistic of F, you get the value is 10.06. So it must be something around here. Okay, something around here that is referred to 10.06. Okay, so it shows that it falls in the rejection region. Okay, so what we are going to conclude, we can conclude that we reject the null hypothesis, HO, and conclude that there is a difference of seedling growth due to soil preparation. Okay, so in this situation also, okay, in this situation also, it stated that although not a primary importance, okay, so that means the F statistic of blocks, that is 10.88, okay, is not a primary importance. Okay, notice that the block or the location will also significantly different with F equal to 0.88. So that means if we are going to compare with the value of the blocks, the F statistic of block, that is 10.88, okay, so 10.88 is also falls in the rejection region here. Okay, so we can also conclude, so because in this situation, the both F statistic value for treatment and blocks is fall in the rejection region, so we can only conclude once. That means we can conclude that we reject the null hypothesis and conclude that there is a difference of seedling growth due to soil preparation. But let's say, what if, for example, the value of F statistic for treatments and block are very different? Okay, maybe let's say the value of treatment is 10.06, but the value for F statistic for blocks maybe 4 point, let's say 4.20. Okay, so that means the value of F statistic for treatments is fall in our rejection region. But now the F statistic for block, because that is 4.20, so it is something around here. So something around here, 4.20. So it shows that it is not fall in the rejection region, isn't it? So what we are going to do if this situation is occur? So if this situation is occur, we must conclude two different conclusion. So the first one, we are going to say that we are going to reject the null hypothesis, okay, for soil preparation of that is referred to the treatments, okay, and we conclude that there is a difference of the seedling growth due to soil preparation, and we can also conclude the second conclusion, that is we fail to reject the null hypothesis, and we are conclude that there is no difference of seedling growth due to location. Okay, not due to soil preparation, but due to the location or the blocks. Okay. Okay, however, okay, if we want to further the analysis or proceed the other analysis, it is same like one-way ANOVA. We only can further our analysis if we reject our null hypothesis. Okay, so if we want to further our analysis, okay, if in this situations, okay, both value of F statistic that is for treatment and block is fall in the rejection region. So we can further the analysis by using the Taki methods. So let's say if the conditions like I mentioned you, if one of the value of F statistic is fall in rejection region and another one is not fall in rejection region, so we just can proceed our further analysis that with the value that have the with the situation that we are reject the null hypothesis. Okay, so the situation is same like one-way ANOVA. If we are able and success to reject the null hypothesis, then only then we can proceed our next analysis by using Taki method. Okay, but usually we are not going to use the value of F statistic for blocks, but we are going to use the F value of F statistic value of a treatment to compare our analysis or to reject or accept our hypothesis. Okay. So now we can proceed our further analysis because we are success to reject our null hypothesis. Okay, so this is the formula. Okay, if we want to further our analysis for treatment means and also for block means. Okay, so you can choose either one. Like I said, if you choose the treatment, so you just proceed with treatment means formula. If you use the value of F statistic for block means, so just proceed with the difference in block means formula. Okay, so the value is where T treatments bar equal to treatment divided by block, and B is block bar equal to B divided by treatment. Okay, so please don't get confused also with this formula. Okay, please refer carefully to the each formula. Okay, so the value of S is equal to square root of MSE, and T is referred to the error degree of freedom of error. Okay, so T is referred to the degree of freedom of error. Okay. So this is the way how we are going to compare the treatment means and compare the block means. So same like one-way ANOVA, okay, we are going to refer to the value of the omega. Okay, the value of the omega. But the difference is just the formula that have been used for treatment means and for block means. Okay, so as I said, the value of S is equal to square root of MSE. So this is referred to square root of MSE. Okay, and the total value, the degree of freedom, for both value here is referred to the degree of freedom of error. Okay, and how also to get this value? Okay, both these two value. Okay, that is the value of Q alpha, K and the F, treatment and degree of freedom of error. We can refer to the Taki table. So table 11 means the Taki table. Okay, refer to Taki table. So in this situation, okay, if any pair of means is differ by more than the value of omega, so if any pair of the means, okay, that we are going to compare is more than the value of omega, so we are going to declare that there is the difference. Okay, so based on the situations, okay, now same like one-way ANOVA, okay, we are going to get the value of mean for each of the treatment. Okay, so how to get the mean? So the total value of the treatment divided by the value of the value of the not the block, the value of the treatment. Okay, the value of each block, okay, and the value of each block, and then divide by the value of the treatment. Okay, so for A, okay, for block A, okay, it is referred to no preparation. Okay, so it is 50 divided by 4. And for fertilization, that is B, is referred to 64 divided also by 4. And the burning, that is C, is also divided by 4. So the total mean is 12.5, 16, and 12. Okay, okay, and then we need to get the value of the omega. Okay, let's say we want to get the value of omega for different means for treatment. Okay, so we must refer to the formula for different means for treatment. So let's say the value of the alpha that has been given is 0.05. Okay, 0.05. And now this is referred to the value of K. Okay, let's see the. Okay, it refers to the value of K and the F for treatment mean. So it refers to the value of K and the F. So this is the value of K. Okay, and this is referred to the degree of freedom of error. So the degree of freedom error. So the K is referred to the treatment. So the treatment is 3. Okay, the treatment is 3. That is ABC. The treatment is 3. That is no preparation, fertilization, and burning. And the degree of freedom for error is 6. Okay, so now how to get this value? So we refer to the Taki table. And first, the degree of freedom of K is 3. So this one. And the value of K that is referred to degree of freedom of the enumerator, and the 6 is referred to degree of freedom of error. Okay, That is the denominator. That is 6 from here. So it is 4.34. Okay, so 4.34 times by square root of value of S. Okay, you can refer back to the previous calculation. Okay, in your table when you convert the data, you convert the analysis. So you just convert into this formula the value of S and the value of N. Okay, that is referred to the the value of block. Okay, so divide by the value of block here. That is 4 block. Okay, so when you calculate, you will get 2.98. So this is the cut-off point for comparison with the value of F statistic and the omega. So the value of omega is 2.98. So same like one-way ANOVA, it is more easier to us to create this comparison, to make the comparison like this. Okay, so in this situation, we are going to compare the mean 1 with mean 2, that is treatment 1 and 2, and then treatment 1 with treatment 3, and then treatment 2 with treatment 3. Okay, so when we convert all the value that we have calculated, for example, let's say this X1 or the mean 1 and mean 2 for treatment 1 and treatment 2. Okay, so it refers to 12.5 and 16. Okay, so the highest value, that is 16, minus with the lowest value, that is 12.5, so we get 3.5. Okay, so same also for another comparison. Okay, so we get the difference between the means 1 and means 3, that is treatment 1 and treatment 3 is 0.5, and means 2 and means 3, that is treatment 2 and treatment 3, we are going to get 4.0. So now we are going to compare with the value of omega, that is 2.98. So now the first comparison, that is 3.5 is greater than 2.98, and 0.5 is less than 2.98, and 4.0 is greater than 2.98. So now we have two conditions. Okay, if you only have one value that is greater than the value of omega, okay, so you just simply conclude like one-way ANOVA, like what we have concluded in one-way ANOVA. But now the value is, we have two different comparison that have the value greater than 2.98. Okay, so now we can see that the difference comparison is occur between treatment 1 and treatment 2, and the other differences is between treatment 2 and treatment 3. Okay, in this situation, we are going to see that both comparisons are referred to the treatment 2. Isn't it? Treatment 2. So treatment 2, if you refer to the table, that is referred to group B, that is fertilization. Okay, so it refers to the fertilization. So what we can conclude here? So we can conclude that there is a significant difference in average growth only occurs when the soil has been fertilized. Okay, why we can conclude like this? Because we get both the difference, the comparison difference between means is referred to treatment 2, that is referred to fertilization. So we can conclude that a significant difference in average growth only occurs when the soil has been fertilized. Okay, so this is also the other ways on how we can use to make a comparison by list the sample means from smallest to the largest and compare with the value of omega. Okay, right. So that is the analysis on how to use two-way ANOVA by using completely randomized block design or CRBD design. Okay, so please try this example, and I will also provide another example, and I will share in Putra Blast the lecture notes and the other short videos for this two-way ANOVA. Okay, so you can refer to that. And if you have any question, you can ask me. And please try to do please try to discuss with your friends regarding this topic. Okay. Okay, so that's all for today's lesson. Thank you, and I wish you all the best.